Hello, everyone. My name is Sushant Banjara. I'm a fourth-year PhD student at the University of Chicago, Harris School of Public Policy. And today I'll be talking about the economic and environmental impacts of sand mining in India. Besides talking about the results, my goal throughout this presentation is also to convince you why sand mining is important. And I'll also be talking about things that support my arguments. All right, in the last 2 decades or so, low and middle income countries has experienced massive urbanization, and it is expected to continue for a few more decades to come. For instance, India and Nigeria alone is expected to have more than 500 million people in the urban area by 2050. This has naturally caused a boom in construction industries in these places, as seen by the stats that 8% of GDP in India comes from construction sector. And this boom, interestingly, is fueled by sand because sand is the essential component of most modern construction materials like concrete, cement, asphalt, mortar, glass, etc. And this has caused an increase in sand mining in the last few years, so much so that about 50 billion tons of sand and gravel is extracted every year around the world, and that accounts for 85% of all the mineral extraction that's going on. So this tells you about the scale of operation that is happening around the world. Where does this sand come from? Sad to say, the vast swaths of desert we see around the world contributes none of the sand to the construction work because they are virtually useless. So sand primarily comes from coastal areas and rivers, which are very sensitive ecosystems. As a result, sand mining has been widely criticized all around the world, primarily due to its negative impact on environment, particularly flooding. And while we anecdotally understand how sand mining might impact flooding, there has been a dearth of systematic empirical evidence measuring these impacts. At the same time, there might also be potentially large benefits of sand mining, particularly in lower middle income countries. It's a booming industry, so if you are a worker and working in sand mining industry, you might command a higher wage than as opposed to working in traditional sectors such as agriculture. And while there might be economy-wide benefits, for example, if sand mining happens, it allows for infrastructure construction, allows for housing construction, there are also local benefits that people in the community who are engaged in sand mining might get just by being a part of that operation. And we believe that these local gains and losses and its distribution is crucial input to sand mining policy, especially in countries like India, where property rights are weakly defined or enforced, and local political economy has a lot of influence on how extraction decisions are made. And given, as I mentioned in the previous slide, given we lack these basic measurements of losses and gains, attempts to regulate sand mining has been not very effective, partly because poor enforcement and also because high returns or high rewards to engage in sand mining despite its illegality. As a result, there are large-scale illegal sand mining in at least 70 countries in the world. And given this background, an overarching policy question is what sand mining policies could be both welfare improving, which is whether or not it internalizes the environmental and economic externalities, and also are feasible to enforce. So locally, whether or not people who are engaged or who will be engaged in sand mining find it incentive compatible. But there is currently a vacuum of measurements that allow us to sort of get to that question directly. So we start with three smaller questions. The first is how big exactly are the sand mining externalities? And we answer this question by estimating the magnitude of flooding effect of sand mining in India. We also ask, given the cost, if there are significant costs, why do river adjacent communities are engaged in sand mining? And we try to answer that question by estimating the economic benefits that comes from sand mining at the local level. And we also see if there are any distributional consequences, and in particular heterogeneous effects by base nightlights data within each mining village and by cost. And to do this, we use staggered difference in difference framework, where we compare existing mines to potential mines to answer these questions in the context of Bihar. Yes. Yes. I'll talk in the subsequent slides about existing mines and potential.
Great. This is so convinced me of the importance and clearly given the magnitude and scale in and of itself, understanding it in this context is going to be hugely important. I wonder if you could say something about whether there are sort of a priori reasons to think that the spatial scale or structure of the externalities or something is conceptually distinct from thinking about mining of other minerals, where there's a little bit of a literature already trying to trade off the kind of local economic gains from local environmental externalities, which are different in that case, toxics and so on. But whether there's something conceptually distinct about sand, notwithstanding the fact that, of course, it's very important and you've motivated that very clearly.
Yes, we have some idea of why it is distinct, but we haven't sort of completely formalized it. The general idea is that it's easier to mine sand because you don't have to sort of, as opposed to mining some kind of ore, you don't have to sort of undergo any process, take the sort of raw materials under any kind of processing, and it's also relatively ubiquitous compared to many other mining, so it's not concentrated, and so enforcement might be relatively difficult. While, for example, in case of gold mining, for most areas, we know where gold is sort of found.
I guess that makes it kind of different in the sense that if there's lots of places you can take sand, then presumably part of the solution is to take sand where it's less damaging.
Yes.
And also, I guess the other question is, are there substitutes for sand? I have no idea. Presumably not, if you're making cement, you need sand.
Right.
Is this really about, your bid really about reducing mining in areas that have particular bad environmental?
And motivation is that we don't get into where it is sort of better to mine sand. We don't do any kind of modeling in terms of answering those questions. But now we're just trying to understand the basic impacts and whether or not sort of economic impacts are commensurate with the negative environmental externalities. But it relates to that.
The economic benefits, for example, building, the benefit of sand. Would that be factoring on the benefit side? Because if you didn't have sand, then you could do a bunch of things.
So no, so the idea is that we only want to, so as I mentioned, there are larger economy-wide benefits of mining sand, but whether or not sand mining happens in a particular area, whether or not people there engage in sand mining, considering the potential environmental externalities, we only want to look at the local. And that determines whether or not sand mining happens in that place. And this doesn't take into account the economy-wide benefits, in which case, even if we see local externalities, it might be sort of rational to mine sand if we look at the economy level.
Is it easy if I mine sand in Bihar to send it anywhere? Like, is it super transportable, or do I need to mine sand close to where it's going to be put into cementers?
It's not as transportable as something like gold, but Bihar in particular has this reputation of having good quality sand. So Bihar sand is transported to UP based on what we know as far as Delhi. So it is relatively transportable, not as much as it cannot be globally sort of traded like many other minerals. All right, before we go to the analysis and results, why Bihar? It's why, as you can see, it lies at the northernmost part of the Gangetic Plains and is widely considered to be the most flood-prone state in India. It's a large construction sector, about 9% of GDP of the state. And there's widespread sand mining in this area, and this set of conditions makes it a nice sort of context to study these questions. So what we find with our analysis is sand mining increases flooding locally. Perhaps not so surprising. A little surprising maybe that it also increases economic activities or economic benefits as measured by night lights. And we also find that both baseline rich areas and poor areas see an increase in night lights. Yes.
Do you have a sense of how, to what extent this sand mining is artisanal? Like, do farmers or people use it as an adaptation strategy when their agricultural areas fall to go to sand mining? Because I think there's a literature on how artisanal mining in minerals is increasingly used as adaptation when they face income shocks.
So sand mining in general is partly sort of well, before I answer that question, it's relatively artisanal in general, so you don't need heavy machineries or, large equipments like coal mining or something like that. So it's usually simple excavators, even if it's sort of capital incentives, capital incentive sand mining, but it's like a mix between artisanal mining and intensive mining, which is not as capital intensive as mining other minerals like, let's say, gold or iron. But I can't sort of say anything about the second part of the question, which is are people mining sand as a source of adaptation to it? Any other questions?
I guess, sorry, for what is illegal? You said it's illegal sand mining and then non-illegal. How do you become illegal?
So I'll answer that question partly in subsequent slide, but basic idea is that you can mine sand after sort of leasing certain sort of area from the government or without doing that. But based on our preliminary field work, at least in India, most of the illegal sand mining is happening on the intensive margin, since you have a permit, but you might mine, more than what is
So they get some sort of permit before they begin operation.
right.
One quick question. Do other forms of mining also increase flooding risk?
Depends if you are mining close to the river and if it's sort of destroying the riparian zone or the banks of the river, then yes. But sand mining particularly is heavily correlated with there being a river. So this is, in this case, we are more sort of confident that this might have an impact on flooding. For others, sorts of mining, it is only sort of possible when there is a river or a source of water nearby.
I just wanted to suggest that that also makes it conceptually distinct from the externalities of other forms of mining because it affects the distribution of benefits and losses and thus the politically
Right.
feasible.
Yeah, thank you very much. I didn't think about that. But again, so both rich and baseline rich and poor areas see an increase in night lights in response to mining. And this might, paint a relatively rosy picture that both it's equitable in some sense, but when we do similar analysis along the caste lines, which is an important margin of inequity and discrimination in India, we don't see the same effects. So the most marginalized groups, namely scheduled castes and scheduled tribes, don't see an increase in their wealth in response to sand mining. So now I'll talk briefly about the setting to give you a sense of what a sand mining operation looks like and what the economy surrounding sand mining at the local level looks like in India. So this is a Google map image of a village with two distinct sand mining locations. So the orange polygon that you see is legally demarcated sand mining area, which is demarcated by the government. And as you can see, they are very close to agricultural land and also to the settlements. And there is no reason to believe that there is any negative externality that to the environment that comes from sand mining is limited within that polygon. And to account for that fact, we take this larger donut or larger circular area that is centered at the center of the mine to be our unit of analysis so that we can look at the spillover effects. Well, not spillover effects, but the environmental impact of sand mining in these areas. So when I talk about sand mining and its impact at the mine level, we should think of this larger circle throughout these slides.
So that, presumably in the larger circle, just looking at this, that would cover some private land rather than government land.
Yes.
So if you're on your own land, are you allowed to then extract something?
To be honest, I'm not sure about the private land thing, but the mines are are only demarcated within the government land.
Okay.
But I have to look into that. And I'll talk briefly about what the local sand mining economy looks like, and this is based on preliminary fieldwork that we did in Bihar. So usually if you're a part of landed community, then you're either working as a partner in a large sand mining operation, you may lease out your land to the mining companies, or you can own a transportation business where you buy a fleet of vehicles and transport sand from mines to the market. If you're a relatively small landholder, you're usually working as a driver, a labor supervisor, or own a small transportation vehicle that is used to transport sand from mines to the market. And often, if you're part of a landless community, you usually work as a laborer that's either extracting sand or loading and unloading sand from trucks. And some of the economic consequences of this reshuffling is of course, you have economic externality that comes from the environmental externality, for instance, flooding, but there is also land reallocation. So that land you traditionally used for agriculture might be shifted to store sand or to make way for the trucks to the river, and also labor reallocation. And the economic impacts that we see or that we measure is effectively the impacts of these economic reshuffling that's happening in the village. Let's talk about our data and empirical strategy. So our primary source of data is what we call as district survey report, which is this comprehensive information or comprehensive report on all existing and potential sand mines in Bihar. They are published separately by each district, so most of these mining leases are happening at the district level. And in our data set, we have 1,431 mine locations and 16 districts in Bihar, which is out of 38 districts. And in that sample, we have 844 existing mines rolled out between 2016 and 2021, and we use that as a treated group. And we have 587 potential mines. What potential mines are they are delineated, demarcated, and surveyed by the government for the express purpose of leasing them out as sand mines in the future, but haven't been leased out yet. And we use this as never treated group. And our identifying assumption is to the extent that we restrict our comparison within a district and a river, these areas are similar enough and they follow parallel trends. Of course, we're trying to get more details into the administrative process of how this is being done so we can be more confident about our identifying assumption. But for now, let me get back to you. We can show a balance check on the trends between villages with existing mines and potential mines for a range of census-related variables. And we see we don't see any evidence of them being distinct in terms of trend. Yes.
So there's no illegal mining in the potential mines?
So for now, we have done we have sampled a subset and looked at the Google images of these potential mines, and we don't see any mining happening while there are potential mines. But we have just hired an RA to do a comprehensive search for that. So we'll look at all the mines in our database.
I see, but the Google images is one point in time.
No, you can look throughout the
So you're saying Sentinel images from Google Earth, not Google Maps image.
So Google Earth, yes, Sentinel images from Google Earth, yes. Any other questions?
I guess, so is this done mainly on river?
Yes.
So is it possible that the sand that's closest to roads and people's middle government owned, presumably, is mined first, and then the thing you're comparing to those ones that are like further down the river, and so that's not such a great comparison, right? Because one is exploitable quickly, and the other is maybe it's sort of a higher cost in nature. You're comparing them as if they're kind of, the same.
Right.
How do you kind of deal with that?
So we don't have the timeline of road infrastructure across India, but we have data for road infrastructure for 2011, and at least for that year, we don't see a difference between these two areas. But we're trying to find a timeline of road infrastructure and sort of do the same thing over time, because we get this question quite often. Yes.
I guess one thing that might help is like, why is a potential site not yet a site? Is it because it was offered up for lease and no one wanted the lease, or is it just like how? Why are they still potential sites? I guess is my.
Yes, as I mentioned, we need to get into more institutional details to see what has happened. In subset, we can see the auction process, And at least for those the subset that we could see, we don't see that happening. It's not that a mine is on the market for a long time and is a potential market. It's that it hasn't been offered in the market yet. So let's get to the results. My first result is in relation to flooding. Here, as I mentioned, we're comparing within district and within mine. So we have within district and river. So we have river time fixed effects, district river time fixed effects. Alpha is mine fixed effects, and our outcome is inundation rate. So this is the fraction of the larger circle that we saw that is inundated in a given month, averaged over a year. And when you see this, we see about 25% increase in inundation rate compared to the treatment baseline within that circle, which we consider very significant. And since we have heard news about flooding in Bihar so much, and it is considered to be one of the most flood-prone states in the country, that is at the treatment baseline 0.1, and when we see an increase of about 25%, that's very significant. Yes.
Is this welfare improving or reducing? Because flood also means you have better soil in the further years, right, in Bihar?
So to be honest, we never really thought about it that way. We have only thought of flood as a disaster, particularly in Bihar, especially. Maybe we have to sort of look into it in more detail, but our idea is that for a place that receives so much rainfall, probably flood in additional sort of inundation is damaging as compared to areas where rainfall is low and it's more or less drought stricken. But that's the answer I have for now. Our second result is the night lights. Now, the difference between the previous analysis and this is that this is happening at the village level, because we don't necessarily want to look just since this is an economic or social sort of outcome, we want to include the entire sort of community, and that is the village. So we match each mine with a village, and then we do this analysis. One might be, let me see if yes. So one might be sort of concerned that there is an overlap between mine and village, and that might lead to mechanical increase in night lights due to nighttime mining. To alleviate that concern, we exclude any nightlight cell that overlaps with mining areas. We see a significant increase in night lights in mining villages compared to villages that only has potential mines, about 15% increase compared to the treatment baseline. This is again significant. And I'll talk about more limitations. I'll talk about limitations of how we can interpret or how we cannot interpret these results. But before that, we also want to look at, are these equally unequally distributed? For that,
it might be worth, going back to the question before, to look at something like the economic census, or see whether either because agriculture became more productive, or people get returns from sand mining, more like little businesses. Because I think the economic census covers like even tiny businesses came up as a result. Now, of course, that's difficult. It's far apart. But the idea might be that as you got surpluses from sand mining, you did other businesses, and that makes it the night lights go up.
yes, as you mentioned, one of the issues with using economic census is that they are very far apart, and so
you can also now use these satellites that pick up new buildings, and then see whether kind of in sand mining areas, new buildings, bigger ones, in these areas more than in the areas that are comparison.
yes, that is a great idea.
I think it's broadly relating to this kind of mechanisms question. So it's obviously excluding the mine itself, the mine itself, but is there some notion that you'd also want to exclude if it's, I don't know, trucks driving to and from, then that's showing up, and what is the set of related services that you see as a mechanism versus a confounder here? And looking at kind of distinct business-related outcomes, one could imagine there you're talking about this kind of spillover growth and so on, but there may be other categories that you'd wish to exclude. I don't know how finely you're able to pick up things like transportation routes, or is that part of your mechanism?
So yes, we have thought of it as a potential mechanism where once sand mining is sort of developed in a particular place, maybe in response to that, transportation infrastructure comes in.
Would the nightlight signal be about developing transportation infrastructure, which one could think of as a mechanism for fostering border growth, or just a bunch of trucks driving to and from the mine, which is part of the kind of direct mining activity that, as I understand it, you're trying to exclude from that line in red?
Right. So I was previously talking about the first point you mentioned, but for the second point, we haven't quite sort of pinned down how we can sort of exclude the nightlights effect or contamination that comes from trucks.
I don't think it'll be binary, but perhaps there are kind of gradations like that where you, and if we take out the feeder rows and this kind of thing, just to see, I think that either way it's very interesting.
Right, we can do something like that. Maybe take out smaller roads or larger roads from the area and then see how that might change things. Okay. And to do the heterogeneity analysis, now we go into within village analysis. So we divide nightlight cells within a village. So rich or poor, the way we do that is we consider a village cell rich if it has more, well, its nightlight value is higher than 80 percentile. And we aggregate GSS population cell grids at the nightlight cell level, and we exclude any cell that has a population of less than 10, because we don't want to sort of include mechanical zeros in our analysis. And we also exclude cells that has overlapping mines on it. And we do separate regressions for ex-ante rich and ex-ante poor cells. And the analysis is similar. The only difference is it's now happening at the cell level, not the village or mine level. And we see there's about 17% increase in both rich cells and poor cells at the baseline compared to the baseline level, which is both significant. And this gives part of the picture about how the economic gains are distributed. But again, we also think that caste is an important sort of distinction or sort of delineation of how sort of benefits are distributed within a given community in India. So we do a caste level analysis, but this is very basic given the restrictions in our data. We don't see a panel of observations, so we cannot do a difference in difference. So what we do is we take a 2014 NFHS survey, and there is an asset index in that survey, and we sort of look at the difference, average difference between mining villages and non-mining villages before mining happened, and we do the same for 2019, and we see that there is significant difference in the mining villages, but only for higher caste and other backward classes group, and not for scheduled caste and scheduled tribe. So that gives us some sort of idea about maybe it's not as equitable as we see from the nightlights information.
I mean, you could have added village fixed effects here, right? And just done within the same village, UC versus SESG.
Yes, but villages are very small in India, so we don't even see repeated observation in each village.
Because it's an
Yeah. So in conclusion, we show that there are both benefits and costs of sand mining and how they're distributed in a given village. And it sort of, if you ask about why sand mining persists when there is this overarching narrative, at least in Indian sort of news media, about how it only has negative impacts, we provide part of an explanation that there are potential benefits at the local level, even if we sort of ignore the economy-wide benefits of improved infrastructure and improved construction, and that might be one of the explanations why sand mining is happening. But of course, there are also other explanations that are possible. Cooperation by powerful, or maybe the costs that comes from flooding are not fully internalized by the local people, or maybe there is something else we haven't yet thought about. Given the nature of our analysis, we cannot sort of rule out the explanations fully yet. But we have recently started a survey And we hope to sort of get more granular information and able to get mechanisms of how things are working in the field and maybe have more results in the future. Very much.